Hi, I'm Andy Weyenberg with Miller Welders, and today we're at the 2022 SEMA show in Vegas. And I'm joined by one of the premier coach builders in the industry, Adrian Casados. Adrian, tell us a little bit about your business.
So I'm Adrian. I own a company called Casados Design, and we specialize in high-end hot rods, custom cars, basically just anything that you can think of out of metal. So what we're known for is building a lot of really complex and interesting shapes using traditional coach building techniques. So we use techniques that were used in the factories for the last 100 years to build and design cars to create custom and modern cars for the industry.
Yeah, it's brilliant. I love it. And I'm totally enthralled on how he welds the stuff together because he primarily uses TIG. And in today's industry, that's kind of unusual because you'll find most people hit the easy button and they grab the MIG welder and they'll start spotting their panels and stuff together. But Adrian TIG welds pretty much everything together, and then he works the metal. So what I'd like to know, and I'm sure everybody wants to hear, is why TIG in the first place, and give me a couple of quick tips on what makes it better.
Okay, so when we do high-end cars, a lot of cars get metal finish, meaning if we weld a patch in or we build a panel, or basically when the whole car is done, we're building it like it would be from factory, which means that there's no visible weld seams and it looks like a manufactured car. So to do that requires a lot of hammering and pushing things around and moving and shaping metal. And so it kind of goes to theory of like quenching metal. When you heat and cool metal very, very quickly, it tends to get very, very brittle, very work hardened. And so there's a sweet spot. You can make something that's very, very brittle and very, very hard, but it tends to crack and snap. You can also make something that won't crack and snap, but it tends to be too soft. So if we think of in terms of like a good knife, we want something that's very strong, very rigid, but also has a little bit of flex to it. So the same is true when we're working our panels and doing our sheet metal shaping. So when we MIG weld, the MIG welding process, it tends to heat and cool very rapidly. And so TIG welding, just the way it works, it tends to heat the metal up a little bit mellower and then bring it back down. And so just that slight difference makes the sweet spot of a panel that's workable. You can hammer on it, beat on it, and just kind of do your things that you need to metal finish, but it doesn't get too hard that it starts to get fatigue, stress, and crack. So that's primarily why we TIG weld in a nutshell.
So it makes that working time frame much longer than say a regular MIG weld would be.
Yeah. So
does it, and it doesn't eliminate warping though. Like you're still, you're putting heat in it, right? So you're still warping the piece, but it gives you the time to actually get it to straighten out to the shape you want.
Yeah, so the idea is when you put something in, if you're introducing a new piece of metal or you're just making something new, you essentially don't want to change the makeup of the structure in any way. You want to introduce what's already there and make your weld seams very similar. You want your panel to panel very similar. So yeah, if you TIG weld your panels in like that, the heating and cooling process allows you to essentially create a panel that's similar to the panel next to it.
Okay, so if you're TIG welding steels, and of course, you know your panel thicknesses are it's thin gauge material. So what size filler metal and alloy do you typically use?
So for most of our panels, our exterior panels, we'll use 18 gauge cold roll, which tends to be about 52 thousandths. And then I use almost exclusively 40 thousandths, 45 thousandths ER70S, 2 or 6, either one. And we tend to use 2% thoriated tungsten. And when you weld with that, basically you're kind of introducing the filler wire is what's already there in the panel. So when you work it out and hammer it out and stuff, you don't have a difference of filler material in where the weld seam is.
Gotcha. Okay, fantastic.
And also the 45 thousandths helps a lot with 50 thousandths sheet metal.
Yeah, that's the problem too, because typically your filler metal shouldn't be thicker than your base metal anyway, because you have to introduce enough heat to melt the filler metal without burning holes into the base metal. So,
and to make it even more interesting, sometimes when you're dealing with like historically relevant or classic cars, you're putting new metal in next to old metal. And so what happens is you might have old metal that was originally 53 thousandths, and over the years it's been de-aged and sanded and gotten thinner and thinner. So you might be welding something that goes from 50 thousandths and 50 thousandths all of a sudden to 20 thousandths and 50 thousandths. So having little filler wire and also having a lot of practice on your foot pedal or your hand pedal, very, very important.
So that brings up another point is, you're working the foot pedal. Do you ever work, I know a lot of the newer machines like this Dynasty 300 has pulse capability.
Yes.
And that pulse capability can be programmed into the machine. 100%. So when you're working your panel, do you do short steps and you skip around, or do you start on one end and go to the other?
So this is a big one. I actually talk about this in workshops, and they say there's an old saying that a lie can get around the world faster than the truth can get its boots on, and so, which is funny. But so sometimes you'll see information that just kind of gets out into the zeitgeist, and then it just kind of runs around and it's believed to be truth. So one of the things people ask me about workshops and metal finishing is that, like we're talking about, do we jump around? So if you take it down to basically just heat theory, what happens when you heat and cool a panel? Essentially, when you jump around, what you're doing is you're introducing heat and cooling randomly throughout a panel, which creates pucker. So you're actually making the panel warped worse by using that technique. And somehow that kind of got on, and most people think that's the way to do it. So essentially what you want to do is you like just kind of like a patch panel or whatever. You want to get your panel all lined up, and fitment is super important, right? Like same thing. When you go into a paint booth and start painting, the work's already done. It's going to come out the way it's going to come out. So same thing. The fitment's where the magic happens. Once you start welding, whatever's going to happen is going to happen. So you tack together like every 3/4 of an inch, and then you basically want to start one side and then weld and let it cool as you go all the way across. And what happens is the metal will heat and cool organically in the same way all the way across the panel. So if there is warpage, it tends to kind of move through the panel and work its way out. So I've literally done big door skins with no back access where you'll watch that hump kind of work its way through the door skin.
Yeah.
And by the time you get to the end, it kind of pushes its way out, which is really cool to watch. So
interesting.
Don't jump around. It's not good.
Yeah, okay. Which brings me to another point on the new Dynasty 300. They actually incorporated, we kind of call it soft pulse, but they changed the way the pulse actually works. Instead of being very strong, where it pulses from a minimum amperage to a high amperage, this actually slopes up into those higher and lower amperages. So the appearance is the pulse actually appears softer, and it's more predictable from an operator standpoint. You can actually feel when the machine is actually starting its ramp up. So it tends to also reduce that total heat going into the piece too. So you're not always at a higher amperage point. So the pulse reduces the heat, and like Adrian says, you can start on one side, work your way all the way through the panel, and if you incorporate a pulse, you're actually still going to end up with a little bit less warping.
So one of the ways you'll see that if you start with a large, like especially aluminum conducts heat and electricity much more than steel.
Sure does.
So the workpiece tends to get very, very hot and takes more amperage. So when you use pulse, instead of starting at one end of a panel and you may need 50 amps here, and by the time you get to here it's so hot you only need 20 amps.
Right.
The pulse kind of helps control that a little bit, so the panel itself doesn't heat up so much as you're working.
Yeah,
So,
I like to say welding aluminum is like driving a car downhill and keep speed limit, right? It builds up speed and builds up speed, and you're always monitoring that throttle.
Yep.
So that's the tough
You're
part
always
about
running in
aluminum.
front of the
That's
amperage a little bit,
yeah, that's very cool. So I guess my next project on Real Garage is going to be working on a dash for my 69 Trans Am, and I'm going to be building it out of aluminum.
Okay.
So I planned on using a 3003 alloy.
Yep.
What filler metal would you actually go with?
So 4043 is always a pretty good choice for pretty much any aluminum alloy. You can also use 1100, which is commercially pure aluminum. It tends to be a little bit more docile, but the difference is almost negligible depending. But yeah, 3003 series is it's essentially commercially pure aluminum with a little bit of manganese in it, so it has a little structure.
Yep.
So it'll give you some good rigidity, but it's fantastic to weld. It's fantastic to work.
Yep.
Just really, really good material. So I tend to do the same thing. I'll use like 16th, 4043 or 1100 series for stuff like that, and that works pretty well from ranges of about 40,000 aluminum all the way up to about 80, 90,000
Nice.
as well.
Yeah, I like working with aluminum. That 3003 is easy to form. You can bead roll it, and as far as one of the things that I use a lot, even I build tanks with it, you know, breather tanks and things like that, but this is going to be my first application where I'm going to be building a dash, you know, something longer, you know, something that's got to be flat when it's done, right? So it helps to have some expert input.
So originally the cars were built out of 1100 series, which is just aluminum, right? And so they're beautiful. It's easy to work. It's fantastic. But those cars are so soft.
Yes.
Yeah. You just breathe on them. And, you know what I mean?
Yeah.
So it's scary.
You don't want to lean on it.
Yeah. Those guys are running like 24-hour Le Mans, doing over 100 miles an hour in these cars. It's pretty crazy. But yeah. So the 3003 is basically the slightly upgraded version of that. It gives you everything you want for workability, but it'll be a little bit more rigid.
Yeah.
So,
Yeah. The Dynasty 300 also has the capability to weld aluminum, obviously. So when we get into the aluminum applications and you're using AC, the Dynasty 300 has a real wide amperage range, so you can get down into those 5 amp ranges if you need to, which is extremely low. And it still has pulse capability, but the Dynasty also has the capability of changing its output wave shape. So you can use a sinusoidal waveform, a soft square, or a pure square. Now when you get into these higher square waves, you're actually introducing more heat to the piece. Now, what a lot of the old timers do, and I like to say we're old timers, but we're not. But what we do, yeah, exactly. What we do in this industry is well, maybe we're vintage, right?
I like that.
We're vintage.
Doesn't sound quite so old,
yeah. Yeah. So we like to use that vintage technique, and the older welding machines back in the day were sinusoidal machines, which means they took the AC out of the wall, ran it through a transformer, and that's basically what we welded with. We can duplicate that with this machine. So if you like that real soft, buttery, kind of a wider arc, instead of, when you're working with thinner materials, a lot of people were going, I want more precision. And so you can turn that frequency up and make the arc narrower. Well, in some cases, it's better to have the arc wider and a little bit lazier, because then you're not penetrating so deep too, and you have that burn through and that ripple on the backside. So
sometimes just having the option, the choice to decide what your electricity is going to do, whether it's precise or a little bit wider, is just as key. So a lot of times people will come to, we do workshops a lot, and people will say, what welder should I buy, right? Which is a very loaded question. But I always tell them the main difference between a cheaper welder and a more expensive welder, you notice it when you start doing really precision stuff, right? So in my career, I do a lot of exotic stuff. We do a lot of very, very thin titanium and magnesium and stainless and stuff like that. So when you're trying to hold, like you said, 2-3 amps on the pedal and weld something, and you've got something that's maybe 16 thousandths, that's when you see what your welder can really do. And it's the same that's true of your hoods, right? So if you have a really, really good hood, you start getting down to those really, really low amps, that's when you see what it can do. So,
awesome.
Yeah.
Cool. Hey, well, thanks for coming out and talking to us.
I appreciate it.
I look forward to having you on one of my episodes of Real Garage, and we can really get into some of this in depth.
We'll be doing that soon, and we'll kind of go farther down the rabbit hole. Thanks for having me on.
Thanks. Appreciate it.
All right, cheers.